All right. Trig lecture 322, 323. The student will use logarithms to solve equations that have variables in the exponent. This is a review of stuff that, due to the pandemic, we did not cover last year in Algebra 2 because we got knocked out of school there for quite a while and we lost a lot of time. So I want to review that for you guys, and if you've done it elsewhere, that's dandy, but we're going to go over it a little bit because everybody needs to know how to use properties of logarithms to solve an equation. We're going to use logarithms to solve equations that have variables in the exponent. If you're in Algebra 2 and trigonometry this year, you will have seen this already this year. So you get to do it again, okay? But if you're just in trig, you may not have seen it before. The properties of logarithms that we're going to use today, it's called the power property. And it says that if we have a log of m to the n, we can rewrite this by moving this exponent to a position of a coefficient. It physically moves, and when we move it, it gets larger. Now that may not make a lot of sense, but when I'm working these equations, hopefully by the time I get done working them, it will make sense. And you've got a calculator. Most of you have a calculator that looks something like this. And on there is a little button that says log somewhere. There it is. And we're going to show you what that button is for within the context of equations that have variables in the exponent. So here we go. I'm going to use the property, the power property. We're going to move exponents from a position of an exponent to a position of a coefficient. Here we go. Solve the following. Round your answers to the nearest 10,000th. That is the fourth decimal place, right? We're tenth, hundredths, thousandths, 10,000th. Yep, fourth decimal place. So here we go. We want to solve this. I have a variable in my exponent. The easiest way to do this is just to take the log of both sides of the equation, just like you could add 5 to both sides, or you can divide both sides by 7, or you can do whatever you want to both sides of an equation. As long as you do it to both sides, the equation will remain true. In this case, because the variable's in the exponent, I'm going to take the log of both sides. And all that amounts to is just writing the word log next to each side of the equation. Log of 5n, well, 5 to the n, exponent, and that's supposed to be an n, is equal to log 90, the log of 90. Now I'm going to use the power property. Power property says we can move this from a position of an exponent to a position of a coefficient. That's exactly what I'm going to do. I'm going to move this to here. It's going to get physically larger when I do. n log 5 is equal to log 90. Now I want to get n by itself. I have n log 5. That means n times log 5. So to get n by itself, I'm going to divide both sides by log 5. This will give me, these will cancel. It'll give me n equals, whatever this is will be my answer, and I'm going to round it rather, to the nearest 10,000th. That's the fourth decimal place. You're going to take your calculator and go log 90 with your calculator, just hit the log button and 90, divided by, or you could use the fraction bar. And it's always a good idea when you're dividing logarithms and whatnot to put the bottom of your fraction in parentheses, even if you don't need to. It won't hurt anything. It's just a good habit to get into, and that way your calculator won't misinterpret what you're trying to do. So we're going to do this and round it to the nearest 10,000th, the fourth decimal place. Here we go, log 90. There's my log button. Divided by log, parenthesis, log 5. Close parenthesis, equals. I've got 2.7959. What I actually got was 5, 8, 8, 8, 9, 4, 7. And this continued on. It'll never end. It'll never repeat. I'm asked to round it to the nearest 10,000th. So that's the fourth decimal place. because this is a 5 or greater, it's greater than 5, that will round up to a 9. So I would call it 2.7959. Which means that if I raise 5 to the 2.7959 power, I'm going to be very close to 90. It's not going to be exact, but it'll be very close. Okay? It'll have this level of precision, rounding to the nearest 10,000. All right, let's take a look at another one. We got 20 to the p power. I want to isolate this, so I'm going to take the log of both sides because my variable is in my exponent. So I got log 20 to the p is equal to log 11. I just took the log of both sides. You just write the word log. And then we move the p to here using the power property of logarithms. Neat little property. Makes life easy. Then I solve it for p. I'm going to divide both sides by the log of 20. If I divide this side by the log of 20, I get p equals, dividing this side by the log of 20 gives me log 11 divided by log 20. Gives me a fraction. This is the exact value of p. If I raise 20 to this value, I'll get exactly 11. But I want to round it to the nearest 10,000, so I'm going to use a calculator. Say log 11 divided by, and I'm going to put it in parentheses, even though I don't need to in this case, just to get in the habit of, make sure that your calculator is going to do what you want it to do. Log, where's my log button? There it is. Log 11 divided by log 20 equals, I got 0.8004 rounded to the nearest 10,000. 0.8. That's if I haven't made a mistake. And I'll check and see. That's approximately 0.8004. Let's see where my answers are. I didn't check my other one either. I want to check these puppies. Oops, that's not, here they are. 2.795, yay! 0.8004, yay! So that's correct. There we go. So if you take your calculator and you raise 20 to this power, 0.8004, it should be very, very close to 11. Pretty neat. Here, what I want to do is I want to isolate the base that's being raised to a variable exponent. This order of operations, you do exponents before you multiply. So I want to get rid of this and isolate the number that's being raised to a variable exponent. So I'm going to divide both sides by -4 to isolate this term that's being raised to the variable power. So this is times, so I'm going to divide. I'm undoing a multiplied -4. This gives me 17 to the x power is equal to, what is that, positive 15? 60 divided by 4 is 15, negative divided by negative is positive. Now I have 17 to the x power is 15, so I'm going to take the log of both sides. I want x. I'm going to use my power property. I'm going to move this to a position of a coefficient. Use some pre-algebra. I want to get x by itself, so I'm going to divide both sides by log 15. That will yield log 17. I said log 15. I'm going to divide both sides by log 17. On this side, that will give me log 15 over log 17. That's what we get if we divide both sides of this by log 17. That's my exact answer. I'm going to now put it into my calculator and get an approximation, which I'm going to round to the 4th decimal place. And I'm going to try not to make any mistakes. Log 15 divided by log 17. And I'm putting that 17 in parentheses. I should be showing that, even though the reason I'm not showing you this is because you don't actually have to do it in this case. But it's a good idea to go ahead and put your denominator in parentheses when you're evaluating. That way your calculator can't misinterpret what you're trying to ask it to do. So this would be 0.9558 if I haven't made any mistakes. And let me check my answer and see if that's correct. Yay! Alrighty, let's take a look at another one. Okay, I've got 11 to the x. I want to isolate this first, so I'm going to subtract 7 from both sides. 41 minus 7, what is that, 34? Now I'm going to take the log of both sides by just writing the word log. There we are, took the log of both sides. Now I'm going to use my power property and move this from a position of an exponent to a position of a coefficient. X log 11 is equal to log 34. And now I'm going to divide both sides by log 11, and x will be all by itself, which is what I want. There's my answer. X is equal to, because these cancel, whatever this is, rounded to the nearest 10,000th, simply because that's what our instructions said to do. And hopefully I haven't made a mistake. So far I haven't, so yay. Log 34 divided by, I'm going to put this in parentheses, even though I don't need to in this case, just a good idea. Log 11. I get 1.4706. Which means if I plug that in right here, evaluate this, add 7, I should get very, very close to 41, if I haven't made any mistakes. And 1.4706, yay! That's an approximation, so I should have an approximation symbol. As always, there are two approximation symbols, an equal sign with a dot up above it, or a squiggly equal sign. That's horrible looking. All right, so there's our two solutions there. Let's go on to the next two. All right, I've got to have a plan here. I want to isolate this term, so I'm going to add 10 to both sides, then take the log of both sides, and then get rid of that 4. That's the plan. So here we go. I'm adding 10 to both sides. I'm going to do this in my head. When I added 10 to this, it became a 0. I added 10 to this, I got this. Now I'm going to take the log of both sides. Because I have a variable in my exponent. Now I'm going to use my power property. 4p log 19 is equal to log 87.4. Now I want to get p by itself, so I'm going to divide by 4 and divide by log 19 at the same time. This will give me p on this side. I'm going to divide both sides by 4 log 19. This cancels this, that cancels that, leaves me with p equals this over 4 log 19. I divided both sides by 4 log 19. Hopefully I haven't made a mistake. When you go to evaluate this, make sure that your denominator is in parentheses. You go log 87.4 over, in parentheses this, or you could hit divided by, parentheses this. That way it will divide this whole thing into that. There we go. And try to hit the right buttons. Hopefully I haven't made any mistakes. Log 87.4 divided by parentheses 4 log 19, close parentheses, equals. I get 0.3796-ish. That's an approximation. 0. I'll go ahead and show the 0. 0.3796. If I haven't made any mistakes. And that is the value of p that I can plug in right here, raise 19 to that power, subtract 10 from that, and I'll have 77.4, if I haven't made a mistake. 0.3796, okay? Alrighty, and the last one. I want to isolate this term that has the variable and the exponent, so I want to add 1 to both sides. I'll do it in my head. 20 to the r plus 4 power equals 45. I just added 1 to both sides. I'll go ahead and show it. Now I'm going to take the log of both sides simply by writing the word log next to them. There, I've taken the log of both sides, just that simple. Now I'm going to use my power property, and this is a binomial, so when I move this to a position of a coefficient, it must be in parentheses, because this whole thing, r plus 4, is being multiplied by log 20. If I don't have the parentheses, this will be r plus 4 times log 20, order of operations. We want the whole thing being multiplied by log 20, so we must have this in parentheses. Equals log 45. Now I want to isolate r, so I'm going to divide by log 20. Divide both sides by log 20, that will get this part by itself. I'll go ahead and show that. Log 20 cancels log 20, that's just a fancy 1 times this. Over here it looks like this. And then I have r plus 4, that's what this side turns into. R plus 4 equals this mess. So from back in good old pre-algebra, scroll down a little bit. If I want to solve this for r, I want to just subtract 4. So I subtract 4 from this side, and I subtract 4 from this side. This will give me r is equal to this mess minus 4. If I subtract 4 here, subtract 4 here, log 45 divided by log 20 minus 4. I'm going to perform this operation first and then subtract 4 from it, and that'll give me a value of 4, which a value of r, which I'm going to round to the nearest 10,000th, the 4th decimal place. And hopefully I haven't made any mistakes. Here we go. Log 45 divided by parenthesis log 20. Even though I don't need the parenthesis, I'm going to go ahead and put it in there so my calculator can't possibly misinterpret what I'm asking it to do. Minus 4 equals negative 2.7923. Yay! 0.7293. 3. Rounded to the nearest 10,000th. Okay. Wow, I just almost ran out of space on that one. And I believe that's correct. Let me look one more time. Negative 2.7293. Yay! So that's using logarithms to solve equations that have variables in the exponent. We use the power property of logarithms. Take the log of both sides and then move your variable to a position of a coefficient. And then solve for the variable. Use just basic algebra from there on. Okay? You can do this.